Greetings, folks, and welcome to the Electromaker podcast. This week's episode is a lot of fun, but a little bit weird in some ways, because halfway through it, I had to abandon recording because there was a lot of building noise in the building. And when I came back to record the next day, problems were just as bad as they were before. In fact, you may have just heard a little bit of noise in the background. They are blast spraying the outside of the room that I am working in. I am using some fancy NVIDIA-powered AI noise cancellation tools, so maybe you're not hearing any of this and just think I sound mad. Either way, apologies if this episode takes a strange audio turn about halfway through. I don't think it will be that bad. It's just at the time of recording this podcast intro, I haven't had the chance to edit it and listen. Anyway, this is a quite fun episode because there's a bit of nice symmetry where we talk about wireless serial comms with Ralph S. Bacon on YouTube, and then we look at a much more robust pre-launch project on Crowd Supply that does the same thing, but with step-through debugging. We look at the ESP32 C6, which is the newest module and chip that was announced quite a while ago. I think it was announced like 2 years ago, but it's out now. Well, I say out, you can't buy it, but it is out now, and that is a Wi-Fi 6 Bluetooth Low Energy single-core RISC-V module, which can also do Zigbee, Thread, Matter, all that kind of fun stuff. And there's a few wonderful projects as well. Carl Bugajega makes a return with his self-soldering PCBs, and even Miranda is back with even larger 3D printed things, along with an open source smartwatch, which might be the best one I've ever seen. So, with all of that to get through, let's get on with the podcast. We are going to start this week's show by returning to the YouTube channel of Ralph S. Bacon. Now, if you aren't familiar with Ralph, he has been putting out videos about Arduino for a very long time. I've been watching his videos for at least 5 years at this point. I think his channel's been going for even longer than that, maybe 7 or 8 years. He's covered pretty much every corner of what you can do with an Arduino, and also done some great videos on the ESP32 and various other things as well. However, a recent video that showed up of his grabbed me because it covers such a simple problem from various ways of looking at it. Which is, how do you get a serial output from something which is not directly to hand? Now, this is a video about wireless serial transmission. The serial port on your microcontroller, be it an Arduino, an STM32, or ESP32, all of these controllers have a serial port for you to use for debugging. It's probably pretty much the easiest way to see what is going on inside it. But what happens if you have a project which is enclosed in a box or put on your wall, and you just want to get a rough output of what is going on to debug what might be wrong? You don't want to necessarily get that thing out the box, plug it into a computer. This is where wireless serial comes into play. And these two things that you can see on the screen here are both wireless serial transmitters or transceivers. They can both transmit or receive depending on how they are set up. Now, as with all Ralph S. Bacon videos, sorry, I should say his full name, this isn't just a, hey, look, here's one example of how this works. This looks at multiple hardware units and explains exactly how they work. And as he will show in the video, and spoilers, I'll sum it up, he finds 3 separate units, all of which will work in a basic sense of sending serial code from one Arduino to another, but there are a number of caveats to that. They work in the most basic sense, but they're also supposed to take AT modem commands, and he has great difficulty getting that to work. It is a fantastic video that takes you through every aspect of this subject, really. This isn't just a tutorial on one type of thing. As with most of Ralph's videos, they have a deep educational bent, and underneath this video you will find a link to his GitHub, and his GitHub page has a huge amount of supporting information just to this video, and you'll find that's true of all of his videos. If you are new-ish to Arduino, or you just like fiddling with them and are looking for a specific tutorial on any subject to do with Arduino, Ralph's channel is definitely worth visiting. He has been putting out wonderful videos about this for many years, and this one particularly grabbed me because how often is it that you have a project that you want to just sit in a box somewhere and let it do its thing, but you also want to be able to get some debug information of what is actually going on in the box? Well, wireless serial transmission might just be the answer. We're moving over to ZS Watch. Now, this might be the most together and feature-rich, completely DIY, open-source, open hardware smartwatch I've come across. It's called ZS Watch after the Zephyr project real-time operating system, or Zephyr OS, as I think it's called in some other places. It is the Zephyr smartwatch. Now, let's just define smartwatch for a second. There are Apple Watches, which are basically like little wrist-mounted computers, and then there are fitness watches, which have a bunch of different features, and I'm of the second variety. This is a fitness watch. It does have Bluetooth. It does have a bunch of stuff like it can tell my pulse and it can track my runs, has GPS, blah, 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 all that kind of stuff. But it's not quite the same level as sort of the Wear OS things, like you can literally watch a video on your wrist, which is a little bit too much for me. Same with Apple Watches. This falls more into the fitness watch category, but it is definitely very smart. So version 1 of the watch, which is what you're looking at here, has an nRF52 833 chip. So it's a Bluetooth Low Energy microcontroller from Nordic. It also has a 1.28-inch display, an accelerometer. It does pulse oximetry, has a vibration motor. It has a battery charger and supervisor. It has all of the things you need to put together to make a watch. Now, it's not... This is something that you could build now. You could get the bill of materials, you could get the PCB designs, and you could make your own, but you probably shouldn't. And that is because the maker of this has come across a few problems with this initial design, and rather than just fix those problems, they're coming up with a complete rework for version 2, which is going to be better than this in many ways. So, for example, an updated chip, the nRF5340, is a better MCU, sorry. They're also using a Bosch accelerometer. I know very little about the parts that go into smartwatches and things like that, but I do remember a lot of people starting to use these specific Bosch parts because they're very cheap, I assume, or very good for the price. Like I say, I don't know enough about it. If you do, I'd be very interested to see why Bosch accelerometers suddenly showed up in absolutely everything very quickly. Yes, essentially, it's going to be a better version of the same thing. Now, beyond the fact that this looks very cool, and yeah, having read through the GitHub, and there's some fantastic PCB development imagery here, if it's the kind of thing you like looking at, I certainly do. And it also, shows you a few things of these things working. I particularly like this. This is just a small thing, but this is controlling Spotify on the phone from the wrist. It's one of the big things that a few of the smartwatches are kind of like, hey, this is something you can do, isn't it amazing? Yeah, you can set this up yourself. But yeah, if you are interested in this project, I will be linking it in the description of this video. As I may have already said once in the show, if you're not familiar with our show, everything we talk about is linked in the description of the YouTube video that I talk about it in. You can go and read it up yourself. In fact, most of the time, I suggest you should do because I have limited time to chat about it. But yes, it's a very cool project. I'm really interested to see where this one goes because it is under active development, and version 2 will be showing up at some point. And when it does, we'll definitely be revisiting it on the show. We're moving over to the YouTube channel of Carl Bugeja, whose name I've probably never pronounced right, and I apologize if you ever see this, Carl. However, we've featured Carl on this show several times because he just comes up with the most wonderful, inventive, usually PCB-based projects in his electronics lab. Now, if you are wondering where you may have come across Carl before, especially if you've watched this show, I'd been watching him for a while, but I think the first thing that really caught my eye was the Flex AR, which is this open source flexible actuator. It's a very simple design, but it's a very clever design, and as he says, he made a $2 actuator. I actually ended up buying a few of these, and while there's absolutely no reason I would need this, it's just such a really awesome little idea. I bought 3 of them, and I've literally played with one of them for just a few minutes. If I'm being honest, I bought them mostly because when someone comes up with a cool, simple little idea like this, I like supporting them financially if I'm in the position to do so, and I was at the time. Now, fast forward, as you're seeing here, fast forward a while, there's a bunch of incredible projects on this YouTube channel. If you're not already familiar with it, yeah, definitely head over and subscribe to his channel. Every single video is a treat. He's one of those YouTubers that I get genuinely excited when he uploads, and this one is no different. So as you're seeing at the start of this, he wants to make a PCB that will solder itself. And the general idea behind it is actually quite simple, but it's complicated to get it right, as is always the case. Basically, the idea is you have a PCB and you have the top of the PCB that you want to put your components on, and then you have different layers of that PCB. So what if a few of the layers of that PCB were strips of resistive metal that would heat up when you applied a current across them? Because that would heat up the board, and if you heated it up to the right temperature, then it could solder itself. So, is this the end of having a hot plate and doing reflow soldering and all that kind of stuff? Well, no, of course it's not. But it is a really fun idea. In fact, most of Carl's videos come from that spirit of, can you do this? Why not try and do this? He made a PCB-actuated motor, and of course, there's motors already, but the process of him coming up with it and the inventiveness is what makes his videos so wonderful. And yes, this could be a practical thing. I mean, one day, on all those PCB sites where you audio PCB in, maybe one of the options in the future will be, do you want this to be a self-soldering PCB, yes or no? It could happen. But yes, if you are interested in this and other projects similar to it, I highly recommend Carl's channel, and I'll be linking it below. We're moving over now to Ivan Miranda and his search for ever larger 3D prints. If you're not familiar with Ivan, he's got a YouTube channel and he basically does large 3D printing. That's kind of his thing. In fact, a long time ago, I featured him on the Electromaker Show when he was trying to build an ever larger 3D printer than the one that he had. And if I remember correctly, he used his old large 3D printer to print parts for the new large 3D printer. And yeah, as you can see in the background of this image, he does have a very large 3D printer. Have I said 3D printer enough in this sentence already? Anyway, this video is an update on how to make large Lego blocks using a 3D printer, some of the issues he ran into, and that's kind of it, and that's what makes it so wonderful. This is just a walkthrough of how he's getting on with building a Lego go-kart, and there's a reason behind this. Him and another YouTuber are having a sort of back and forth little battle to see who can build the best full-size Lego go-kart that is 3D printed, and yes, this is his findings so far. But yeah, it's just a really interesting thing for me as well. As someone who uses a 3D printer as a very blunt-edged tool, I very rarely do particularly intricate things with my printers. In fact, it's been a while since I've had the need of it, but I've done things like make cases, make custom little parts of things when I really need them. But he goes into a whole new level of depth, and the way he's talking about, fitting everything together and how to make the cart work and, you know, how to make his 3D prints fit the bearings properly and all this kind of stuff is very, very interesting to me, and I'm sure it will be to you as well. And yeah, bonus here is that you see a miniature version of this thing working already, so you're going to get a nice idea about what happens at the end of the project. So I'll be following this, because also any, back and forth between makers on YouTube I find interesting, especially when they challenge each other to try and make something and it becomes a sort of competition. While I'm not the most competitive person in the world, I do find that an interesting thing to watch, and of course the spirit is always in good fun. So yes, I'll be leaving a link to this in the description. I'll link the Hackaday article as to that's where I ran across it, and of course there's a nice write-up here if you don't have the time to watch the entire video, but it is absolutely worth watching. Ivan has a great way of explaining things, and of course you get to see all of these glorious, huge 3D printed Lego blocks. 3D printed. 3D printed. How many times have I said 3D printed in this? I'm not re-recording it. I hope I didn't say 3D printed the whole way through. If you are enjoying this podcast, do consider heading to electromaker.io and taking a look in our shop. Whether you're looking for your next hobby project beginnings, the bits you need to make something shine and blink and do all the fun stuff, or like a gift for a young maker who might be wanting to get started, or even if you're looking for some serious stuff for your next work project, consider having a look at us, because yeah, we don't have any sponsors, we don't have any advertisements, we just make money from our shop. So yeah, thank you. It is time for the part of the show we call Funding Website Things, because we look at things on funding websites. And today we're looking at two things on crowd supply from two separate angles. One is a project that actually was funded a long time ago, which we are returning to, and the other is a project that is just about to go into the funding stage that I think you might find interesting. So we're going to begin with Puka DSP. Now, I remember talking about this project way back when, and I remember being very, very excited about it. And that is because, well, anyone who has watched the show for more than a couple of episodes will know that microcontrollers and music is my main interest when it comes to programming microcontrollers. One of the first Arduino projects I ever made was trying to work out how to get some sound to come out of the pins, and it was pretty nasty until I, started looking up some real code and all of that kind of stuff, and it kind of blossomed from there for me, at least. And Puka DSP covers a couple of important bases. One is a chip that I understand and know how to program, i.e. the ESP32, and two, a built-in audio codec, which means it'll already be designed to make nice sounds and I won't have to mess around too much with that. This ticked all of the boxes to the extent that I have one right here in my hand. So, Puka DSP, what was it about this particular board that made me excited about getting it? Well, there's a couple of reasons. The first and most obvious one is just that this takes a lot of the stress away from developing your own synthesizers or audio-based projects. The ESP32 is a well-known chip. It's compatible with a lot of different things, including the Arduino IDE, as it mentions there. But the fact that this comes with a built-in audio codec is also a nice touch too. I've messed around with a ESP32 with a DAC before, an I2S DAC, which is, it's a great way to get some sound to come out of it, but obviously you have to do all of that yourself. You have to spin it up yourself, and if you're working with different modules, you need to work out exactly how that might fit into a final design. Whereas this is all on the one board. This could quite happily just sit in a case and basically be a synthesizer. This thing is essentially a synthesizer. It just, if you imagine attaching just a few analog potentiometers and bits and pieces to these GPIO pins, then you're ready to go. You're ready to start programming it. By the way, quick note, if you are watching this show and you notice there's a slight change in continuity just in terms of sound quality, there's two reasons for that. One is that yesterday, halfway through recording the show, they were doing some work in the building and it kind of reached a point where I thought, let's just leave it and I'll keep recording the next day. However, that work is still continuing now, so it is now early morning, and I am using NVIDIA's fancy AI on the graphics card noise cancellation tool, which should be cancelling all the background noise, as far as I can tell, but I don't know. So if there's a notable change in quality between the second half and the first half of the show, I guess we'll find out. So, let's get into a few more details about this. As it says, synthesizers, installations, voice UI, and more. It uses the Pico D4 processor, which is an ESP32 processor. I'm not actually, I'll be the first to admit, I'm not actually all that in on all the differences between all the different ESP32 processors. I know we're going to talk about the ESP32 C6, and I know there's some of the key differences with that one, but off the top of my head, I can never really remember that many of them. But essentially, this does look like a fairly standard ESP32 setup, in that a lot of them do have dual core. I don't understand why it's showing 3 different speeds there. That's, again, something that I should look up at some point. And it has, Bluetooth and Wi-Fi, all the stuff that you would imagine. Now, this is the interesting thing, the Wolfson WM9878 stereo audio codec. This is a pretty decent quality. Well, I tell you what, let's have a quick look at it. Now, here is something a little interesting. I just went on a little rabbit hole just to look up this audio codec for no reason whatsoever. Don't need to do it, but just thought I would. I Googled it, and I thought, oh, okay, there's the data sheet. And I was just about to start talking about it when I realized that this is the wrong number. It's 8978, where this is talking about the WM9878. Having searched on all datasheet for this particular part from Wolfson, it doesn't appear to exist in that configuration. I have a feeling that maybe this is a typo, we're looking at that in a minute. This is a typo, but it's just sort of interesting because I Googled it, and of course, we're not the only people who are reporting on this, and it seems like everyone has mentioned this particular codec, which may or may not exist, which is, of course, exactly what I would have done had I written the blog post before doing this. It's just because I happen to have a dig through here. So, let's leave it at just saying this is a high-quality stereo audio codec, and we'll leave it at that for now. I don't actually know. So, audio line on a stereo 3.5mm connector, audio headphone line out on a stereo 3.5mm connector. Again, just a very practical, useful thing. The audio DAC that I have 2 DAC boards, which are I2S. One of them has a headphone socket, the other one doesn't. You have to wire it yourself, which is not convenient. This just has that already built into the board. Very nice. Breadboard friendly, and yeah, there's a bunch of other reasons, but this is really why I wanted to buy it, just because it's kind of everything that I had been messing around with microcontrollers and audio codecs for a while. Now, is this the only board that does this? No, not by a long stretch. There's loads of boards that do this. I've talked at length about Baylor before and the Baylor project, and in fact, they've probably got better documentation. If you're looking for a board to just learn the basics, a Baylor board will probably suit you much better. I got this specifically because if it is something that I get along with well, it is the kind of next step up. So once I've used something like a Baylor board to prototype what I want a synthesizer to do, I would then port that code over to ESP32 to make it a specific use case and then stick it in a thing. And why do I think this is a better idea for that? Well, it was the price. These are $42 or even $42 for the other version. The Strawberry edition is similar. It has a different hardware configuration. I have one of these too. I anticipate not having to use it yet. I've got this as my sort of stepping stone board. The difference being that if you want to use the extended features of this one, you have to organize that yourself. You'll have to do that with the ESP32 software development kit, and you have to, basically do a respec the hardware on the fly yourself. There is also a Eurorack extension module if you want to go straight into making your own Eurorack instruments. Again, we talked recently about Baylor. In fact, we talked about it today, but we talked recently about Baylor and Gliss, which is their Eurorack module, but also the fact that Baylor modules are specifically great for making Eurorack modules, and Baylor have put out a couple of Eurorack modules called Salt and Pepper, I believe, which have them in. There's no one which is better than the other when it comes to this kind of stuff, but if you are looking for a great way to get started with either audio synthesis or just working with audio in general with a board and a microcontroller that you're probably familiar with, this is probably a good one. I'm not affiliated with these guys in any way, I just really liked it and I bought one, so I thought we'd return to it because they did reach their goal and now you can buy them for $42. I'll leave a link to this one in the description. Moving on to Farpatch. Now, this is a pre-launch project, and it's one that I thought was quite interesting. There's a nice bit of symmetry here, because this links exactly to what we were talking about at the very start of the show. This is a way to remotely debug microcontrollers. The difference being, at the start of the show, we were talking about remote serial, whereas this is remote kind of everything. So the idea being is that this can work with a variety of different microcontrollers. It can leach power from the circuit that the microcontroller is drawing power from, but it allows some advanced debugging alongside things like a wireless serial. So Farpatch is a wireless debugger capable of programming, debugging, and interacting with a wide range of microcontrollers. Powered by the Blackmagic debug software, something I'm not familiar with at all. If you are, let me know in the description, in the comments, sorry, if this is a good thing. Farpatch supports inspecting memory, single-step encode, and adding breakpoints to your project. You don't need to install any drivers, just join Farpatch to your wireless network and let it run in AP mode if you're not near an access point. It's, like I said, there's a lot of symmetry to what we were talking about at the very start of the show. The difference being this is a much more powerful prospect. Now, if you'd like to know more about it, please do come to this page. You can read everything that they have talked about it so far, including the features and specs. And as always, what happens a lot with these crowd supply things, which I think is a fundamentally good thing, there's a comparison chart between this and various different other things that you can use. So, for example, OpenOCD on a Raspberry Pi and J-Link and Blackmagic Probe, the CTX Link, they all have different good things and bad things about them. Of course, these comparison charts are supposed to make the thing that they're talking about look good, but they're also very useful for people that know exactly what they want. And as always with pre-launch projects, you can put your name here if you would like, your email address here if you'd like more information about when this goes live. However, frequently on the show, when I do look at things that are in pre-launch, if they're particularly interesting, I will go back to them when they have launched, because the one thing that pre-launch pages do not and cannot have is a price. So we'll come back to this one later, but Farpatch looks like a great way to extend that idea of having a circuit somewhere in a box on a wall that you want to be able to monitor or even debug or even repatch. And this is a way of doing it without having to take the box off the wall and plug it into your computer. We are closing out this week's show by talking about the ESP32 C6. Now, this is, of course, the newest ESP32 chip from Espressif, and it brings a few exciting things to the table. Now, it was actually announced a little while ago, and we knew it was going to be a Wi-Fi 6 chip, and we knew it would also have Bluetooth Low Energy capability, but a few people were a little surprised that it seemed to be missing some important things that are very important words these days, like thread and matter and Zigbee, things like that. But that was just an oversight by Espressif, it seems, because they are there. Now, using the always wonderful CNX software, we can take a look at the board and the specs, although I'm not going to spend too much time on this because, firstly, it's worth going and reading the CNX software article yourself. They're a fantastic site that are definitely worth supporting, very small team. And also because I'm not going to do it I'm not going to do it complete justice. I will say one thing straight away. It mentions here that it has been released, the ESP32 C6. There are modules and development kits available. However, the module and the development kit and this one here are all out of stock. So the module is out of stock. The development kit is out of stock. This one, which was somehow listed on a different shop, apparently. Anyway, it's also out of stock. Now, Espressif have mentioned in a blog post that they will be finding more stock that will be coming to Mauser and Adafruit soon. Maybe by the time that happens, so maybe that'll have happened by the time the show goes out. I'll leave a link in the description if I see one. But let's get into the actual specs of the board. So, it is a Wi-Fi 6 board. Wi-Fi 6 comes with a number of advantages. I think that Wi-Fi 6 is something we'll have to do a small just feature on in the show just to talk about the changes, because I've read a lot about it, but it hasn't really sunk in for me yet, and I need to really understand all of the terms. I do know that Wi-Fi 6 is going to really bring Wi-Fi closer to the sort of Bluetooth Low Energy range of being able to do things with like small packets, send small packets using a very small amount of power. So it is a single-core RISC-V 32-bit chip clocked up to 160 megahertz with 320 kilobytes of RAM, 520 kilobytes of SRAM. Now here's a bit I don't understand. Low-power RISC-V core at up to 20 megahertz. Now I'm seeing this here, but on the previous article that I read about this last year, I went back because I was sure I hadn't heard anything like this. And it's a single-core processor, and I'm not seeing any low-power processor thing in the block diagram that they showed here. And I looked at the official launch again. And long story short, I'm not really sure what that means. If you do understand what that means, please do tell me. Maybe it means that you can actually just program, you can just configure this to just run like that. So it's an insanely low power device. Not really sure. So 2.4 gigahertz Wi-Fi 6, Bluetooth 5, low energy, and a radio. And here's the important thing, the 802.15.4 radio, which allows for Zigbee 3 and Thread, and it is Matter compatible. And I'm fairly certain that you'll find that, the entire Matter protocol will be well supported on the ESP32. Given how big that's going to be, I'm fairly sure they're going to be getting that in order very quickly if they have not already. And then everything else you'd hope to expect from a board, a very modern development board. One USB Type-C host port, one which is a power port, and then a bunch of GPIO. Now, as mentioned, you can't actually buy this just yet. You will be able to buy it soon, and it says here the new ESP32 C6 module and dev board will work with ESP IDF51, which is currently under development. And there is some basic documentation up here already that you can have a quick look through. But of course, you can have a look through this right now, but there's probably not much point until you can get one of these, which you can't currently. And maybe by the time that happens, there'll be some a little bit more documentation too. But yes, new ESP32 boards. And if you are someone who's into sort of DIY smart home stuff, this will be a quite exciting thing. So, I apologize if I'm a little bit distracted. I'm sure that this noise reduction thing is doing a wonderful job, but there's a hell of a lot of noise happening right outside the door just here. We will see. Well, we will see when it comes to watching the show. If all the comments are just like, "What the hell is that weird noise?" It sounds like someone's blast spraying the outside of the door. It's because someone is blast spraying the outside of the door. So that has been the podcast for this week. Thank you so much for joining me. I hope this episode was okay in terms of audio quality. As I mentioned at the start, I haven't really had a chance to check by the time I record this intro and outro. But of course, if you're hearing it, then I'm assuming it is good enough because I hadn't had to go back and re-record it. Yes, I'm really glad that we're kicking off 2023 with a lot of consistent shows. I had some real difficulty getting them out last year just because of life stuff and illness and all that kind of thing. And it's a really exciting start to the year with all these new things coming out and just some fantastic projects. One thing I did not mention in the show, in the main video show, but I will mention as a podcast, is that if you are someone who is interested in the monthly competitions we've been running on Electromaker, the Electromaker of the Month, it's taking a break in January because it's being reshuffled, because last year we gave away Nordic semiconductor gear the entire year. This year we will be shuffling around prizes, so there will be different prizes from different manufacturers and different types of prizes, so sometimes hardware, sometimes just cash. That's all still being organized, so we're going to start that up again in February. And I think that is everything. So thank you so much for joining me. As always, I hope you have a safe, fun, and creative week, and I will chat to you then.